Hi, thank you for joining me. I'm Craig with Coleman Air. I'm the designer of the C60-PWM and wanted to take a moment to demonstrate it. The C60-PWM is a solid-state controller that we have designed specifically for solar. It handles up to 60 amps of charge current from your solar panels, or it can also function in the diversion mode and power up to 60 amps a diversion. The C60-PWM is made here in Texas. There's no plastic, there's no junk. This controller will last you a very long time. As you can see, there's a massive amount of aluminum. It has aluminum heat sinks, and the entire back of the unit is one plate of aluminum. This allows the heat of the MOSFETs to be rapidly dissipated from the inside of the box to the outside of the box. This is a feature you will not find on many of the foreign-made controllers that are all plastic and have no heat dissipation capability. Those units cannot handle 60 amps on a continuous basis. So let me take a moment just to open this up and show you the inside of the unit. As you can see, two MOSFETs are up underneath the plate, and the MOSFETs then are connected to that back plate, ensuring that any heat from the MOSFETs are dissipated quickly outside of the box. There's a microprocessor here in the middle, the jumper settings for your voltage. The two trim pots at the bottom here, the two rectangle trim pots, are for factory settings so that we can balance the 12 volt and 24 volt system. This allows you to simply move this jumper from 12 volts or 24 volts without having to reconfigure the factory set points. As it comes, the float and bulk are set at 13.5 and 14 volts, or 27 volts and 28 volts, depending on the voltage of your system. The fuse here, which should never blow, prevents overcurrent or overvoltage from damaging your controller. Here we have the back of the meter, and we have two large cutouts for 1-inch conduit, as you can see there. The beautiful LED display allows you to monitor your battery voltage on a real-time basis. If you want to, you can turn off the LED display and the unit will continue to function. On the bottom here we have a test switch. This allows the microprocessor to go into a small test routine to ensure its integrity. It also powers the diversion load if one is attached. So that's pretty much it. On the front panel there's a chart to show the error modes. If the controller does go into overheat, then the red LED will flash exactly 5 times per second. This will look entirely different than the random flashing while it is pulsing your batteries. If the controller goes into an overcurrent condition, that is above 60 amps for a period of time, then both the red and green LED will flash at the same time exactly 5 times per second. The error modes are either 5 seconds or 30 seconds in length, depending on the severity of the error. They will automatically reset. If the controller does not reset after an extended period of time, please make sure you are not running the controller above 60 amps or in a hot environment where it is unable to shed the heat. The C60-PWM is proudly warranted for 1 year. It should last you a lifetime. When the C60-PWM is properly installed and used within its design specification, it can handle just over 1400 watts in the 24 volt position and 700 watts in the 12 volt. You can determine the wattage capability of your solar panels simply by multiplying the number of panels you have by the wattage of each unit. An important consideration when using a PWM charge controller in a solar-based alternate energy system is to ensure that your solar panels are a proper match for your batteries. Normally this is approximately 1.5 times your nominal battery voltage. So on a 12 volt system you want your solar panels to be around 18 volts to up to about 22 volts. When the voltage of your solar panels exceed the 1.5 volt rule of thumb by a great deal, then that extra energy is simply wasted. In addition, the charge controller works harder and has to dissipate more heat. This is certainly not an efficient system, so we recommend approximately 18 to 21 volts on a 12 volt system, and just double that for a 24 volt system. So on a 24 volt system, if you have 24 volt panels, you will place them all in parallel. If you have 12 volt panels on a 24 volt system, you'll put two panels in series, and that pair will then be paired with other panels to create a 24 volt parallel solar system. And this is the same for your batteries. If you're using 6 volt batteries and you have a 12 volt system, then 2 of your 6 volt batteries will go into series. If you have a 24 volt, you obviously will put 4 6 volt batteries into series, creating a 24 volt battery bank. To use 8 batteries in a 24 volt system of 6 volts each, you'll create 2 banks of 24 volt batteries and then tie those 2 banks in parallel. Truly one of my favorite controllers. It's compact, it's all metal, it's rugged, it'll last a lifetime, and it is made here in the USA. Thank you for watching. I'm Craig with Coleman Air.